Hello everyone, welcome to Mind Maps. In this video lecture we are continuing with dyes. Okay, this might be the last lecture on this dyes because we have discussed lots of dyes and there are some more that if you want I can make those videos. Okay, so just comment down below if there's anything you find that is missing. So this is about theories of dye. Okay, how the color takes place. You must be aware of the simple physical or concept that we have been studying in the earlier classes, so I won't go through that, but there are basically in chemistry. Okay, I'll start with three theories. The first one is Witts theory, the second is Quinoid theory, and third is modern theory. So these are pretty easy and basic. So Witts theory, what he says, there are chromophores. Okay, there are certain groups that are known as chromophores. So what it means, chromo means color, chroma means color, and phoron means bearer. Okay, it should be R, bearer. So as you can see, all these groups are electron withdrawing, so they pull the electron from the the ring. Okay, most of the dyes are benzenoid, quinoid compounds. Okay, they are not simple straight chain hydrocarbons. Most of them have conjugation, have a ring system. So these are electron withdrawing groups. These are responsible for color. Okay, these are responsible for color. So Witt said there are certain groups that are known as chromophores, and these are responsible for the color of a dye. Okay, and the second type of groups that we discussed is oxochrome. Okay, oxochrome. So these, as you can see, these are electron donating groups. So what these do is these enhance the color of the compound. These further enhance the color of the compound. Okay, chromophore is responsible for color. Okay, for example, a substance appears yellow. It is because of chromophore. But when that color is brighter and intense, okay, it becomes more orangey or something like that. It is more intense, right? Intensity increases color. For the color, that is oxochrome. Then, and there's a limitation. He did not say why certain compounds act as chromophores or oxochromes. So this was a limitation. The next is quinoid theory. Okay, quinoid theory. So quinoid compounds look something like this. Okay, and throughout the dye lecture we have had a structure that resembles this. Okay, so these can be either ortho or para quinoid structures. These are responsible for the color of the compound, but he did not actually explain that why it happens. So this was the limitation of quinoid theory. And then we have the modern theory. So what happens is, as you can see, dyes have a resonating system. Okay, so there's bond making, breaking, this continuous resonance going on. So there is a change in structure, as a result of which, when a dye absorbs light, it undergoes excitations. Okay, not oxidation, excitations. These can be electronic, vibrational, or rotational. So the electronic transitions, an electron jumps from one level to another and then it comes back. So energy is absorbed, it's released. So these are basically due to pi electrons, right? So what we calculate, how we calculate the color, okay, we can find out. So E2 is excited state and E1 is ground state. So when we take a difference, we get a value of delta E. Now, as you know, delta E is equal to Hc by lambda. delta is hc by lambda, that is Planck's constant velocity of light, and lambda is the wavelength. So this wavelength corresponds to a particular color, so that color we see. So there can be two types of shifts, okay, bathochromic shift or hypsochromic shift. So when the energy difference, okay, E2 minus E1 is small, that means E is inversely proportional to lambda, right? When E is less, lambda is more. So the wavelength shift towards the longer side, it is known as the red shift, okay, or the bathochromic shift, right? We observe a color towards the red, okay, red has a longest wavelength, right? So towards it is known as the red shift. And then when the energy is more, excitation energy is more, lambda is less, so it's hypsochromic shift. So in this video lecture we discussed three theories, okay, Witts theory about auxochrome, chromophores, Quinoid theory, and the modern theory. So modern theory kind of sums up everything, okay. So that was it for this lecture. Thank you for watching.